Unit 4, Section 4. In the past few sections, we've been looking at writing linear equations using slope-intercept form or point-slope form. Well, today we are going to continue writing some linear equations, but we're going to use our graphing calculator to help us find lines of best fit, also known as regression lines. Now, what these are lines that model the relationship between two data sets. Those data sets are plotted on what's known as a scatter plot. All right, now oftentimes there's a relationship between a pair of data points or data sets, such as the number of years old a vehicle is and the cost of that vehicle going down. Or sometimes there's a positive relationship, like the number of hours you've worked and the amount that you get paid. So a correlation in a relationship just talks about whether that data is a positive, negative, or no correlation. And that all depends on the slope of the line of best fit. So you can see here, if I were to draw this green line through the majority of those points, this is going to slope up and to the right, and we'd say that this is a positive linear relationship. Likewise, this next one here in the middle, if I were to draw a line through a lot of those data points, that has a negative slope to it. Well, this third one, you can see that there's no matter what line I draw, it's going to kind of have this, well, there's not going to be a good line that models that data. So here, there's really no pattern, and we're going to say that this has no correlation. All right, as we mentioned, the line of fit is a line on the scatter plot that is really, really close to most of those data points. All right, we try to draw that one as close as we could to fit all those data points in our diagrams above. Well, let's jump into an example here and just see what it means to interpret a scatter plot. When we interpret a scatter plot, it's really important that we look at the title of that plot and the labels on the axes. So you can see here our independent variable is sugar in grams, and our dependent variable is calories. And we're looking at smoothies. So as our smoothies increase in grams of sugar, it looks like they're going to increase in calories as well. So it says the scatter plot shows the amount in grams of sugar and the number of Y calories in 10 different smoothies. And you can tell there's 10 here. If you count all those little dots, there should be 10 of them. It says how many calories are in the smoothie that contains 56 grams of sugar. So we're going to find that here over on our x-axis, 56 grams. If I come up, I see my dot. It looks like it's going to be 270 calories. All right, part B says how many grams of sugar are in the smoothie that contains 320 calories. Now I'm going to locate the 320 on my y-axis, come across, find here's my smoothie, and come down and I see that that's got 70 grams of sugar. Finally, it says what tends to happen to the number of calories as the number of grams of sugar increase. So we want to know what's happening to calories, my y variable, as grams of sugar, my x variable, increases. And you can see here, if I were to draw a line through most of those data points, it looks like it has a positive slope. So it's a positive correlation, and that means as the number of grams increases, and I'm going to draw an up arrow here indicating that it's increasing, as the number of grams increases, so does the number of calories. All right, so this is a positive correlation between grams of sugar and calories. As grams increases, so do the calories. And example 2 just wants you to describe that relationship or the correlation between the data in each scatter plot. So we're going to take a look at the age of a vehicle owned, the number of vehicles owned here, and then the person's age. All right, so is there any kind of relationship? Can you draw a line that fits the majority of that data? Do you see a pattern there? And it doesn't really look like there's a good pattern. So for these two variables, I'm going to say that there is no correlation. Now that's different here in this next one. We got temperature and coat sales at a store. So you can see the coats sold per day as our dependent variable, and our independent variable is the average daily temperature. And as average daily temperature increases here from 35 all the way up to 70 degrees, we see that the number of coats sold per day decreases. And I can draw a pretty good line through the majority of those data points here. So this has a negative correlation. In other words, when the temperature increases, right, the number of coats sold is going to decrease. We'll use some arrow notation there just to imply our increasing and our decreasing. All right, moving on to example 3, and here's where you're going to want to grab your graphing calculator. The table shows the number Y in millions of subscribers to a video sharing website X years since 2010. Write an equation that models the total number of subscribers as a function of the number of years since 2010. Interpret the slope and the y-intercept of the line of best fit. All right, so part A asks us to plot the data on the XY plane at the right. Go ahead and pause the pause the video and go ahead and plot your data, and keeping your years after 2010 on the x-axis, and we can just label these 1, 2, 3, 4, 5, 6. You can skip every other one here, 7. Go all the way out to here to 8. And then on the y-axis, you've got number of subscribers. All right. And here you can go up, let's skip every other line as well. Go 10, 20, 30, 40, 50, 60, 70, 80. Go ahead and pause the video now and label that and plot those data points. Okay, once you have your data points plotted, you can see that they fall in this positive linear relationship, right? So we're going to say that it's probably got a positive correlation to it. We're going to find our line of best fit, which is also known as our regression line. All right, we're going to do this using our graphing calculator. So go ahead and go over to your graphing calculator. And when you're on your graphing calculator, all right, go ahead and clear out whatever might be on your table. And we're going to follow the key sequencing here by pressing Stat right here next to your little thumb pad. And then we're going to enter our data into a couple of lists. So while Edit is highlighted, go ahead and press Enter. And if there's any numbers in your list, arrow up to have the list number highlighted, press Clear, and then Enter back down. All right, so clear out whatever numbers you have in those lists. And we're going to enter into list 1 our X's, which is our years. So go ahead and enter in 0 through 8. All right, once you have 0 through 8 entered in, go over to list 2, and we're going to now enter in the number of subscribers in their millions. Okay, once you have your two data lists entered in, list 1 and list 2, you're going to go back to Stat, arrow over to Calc, and now you're going to scroll down here to number 4 where it says Linear Regression. Press Enter on Linear Regression. Here it's going to ask you which ones you want to use as your X's and Y's. List 1 and list 2 should automatically be put in there already. And you're going to scroll down to Calculate. Go ahead and press Enter on Calculate. And here is your line of best fit. 9.916 is your A value. That's going to be the slope. And 7.11 is going to be your B value. That's going to be your y-intercept. All right, let's go back to our notes. So according to our equation, our line of best fit that our calculator gave us, we said y is equal to 9.96x plus 7.11. Let me just go back and check that. Yep, 9.916 and 7.11. All right, 916. There we go. The correlation coefficient is a number that we can find on our calculator. We'll show you how to get that in class. All right, now it wants us to graph the line of best fit on the XY plane above. So we want a y-intercept of 7.11 and a slope of approximately 10. So every 10 that you go up, you should go over 1. All right, so go ahead and take a second to plot that line of best fit as best you can. Finally, it says to interpret the slope of your line in the context of the problem. Well, remember, slope was 9.916. What does that mean? Well, that's the change in our y variable for every 1 and change in our x variable. Well, our y variable, if we scroll back up, was subscribers in millions, and x was years. So for every year increased, we had approximately 9.916 million more subscribers than the year before. Next, it says interpret the y-intercept of the line of best fit in the context of the problem, and our y-intercept was 7.11. And that was when x was equal to 0. Now, when x is equal to 0, this was the year 2010. So 7.11 is going to refer to about 7.11 million subscribers to our website in the year 2010. All right, again, we're going to talk about correlation coefficient a little bit more in class, and it's going to tell us what we can take away from our line of best fit.